Hello everyone, welcome to Physics Unwrapped YouTube channel. In this channel, you will get concepts related to physics as well as PYQ of various examination.
Let us move on to the next question. In the next question, what we have Laplace transform of 1 plus sine 2t. Yes, let us solve this question, that is Laplace transform of 1 plus sine 2t. So we have a general formula, that is Laplace transformation of sine of at, which is equal to a divided by s square plus a square. Okay. Next, Laplace transformation of 1, which is nothing but 1 divided by s. Using this formula, we can solve this problem. So, Laplace transformation of sine of at, which is equal to a divided by s square plus a square. Instead of a, what we have instead of a, we have 2 here. So Laplace transformation of 1 is what is the value? It is 1 divided by s plus Laplace transformation of sine of 2t, which is equal to 2 divided by s square plus a square. Instead of a square, 2 square, it is 4. So option C is the right option, that is 1 divided by s plus 2 divided by s square plus 4. Yes, let us move on to the next question. What does the next question says? The value of the integral from minus 2 to plus 2 2x plus 3 delta of 3x minus 5 into dx, right? Yes, let us solve this question. What we have in this question, I have written in the next page. I am going to solve this question. Yes, first we need to check whether the x is within this limit. For that, we are going to equivalent this to 0. Yeah, this term to 0. Okay, 3x minus 5, we are equalating to the number 0, that is 3x, which is equal to 5. We got the x value to be 5 by 3. So 5 by 3, it is less than positive 2. So x belongs to this integral. So from the uh, shifting property, what we have, using the shifting property, that is integration from c to d f of x into delta of ax minus b into dx, which is equal to, the solution will be 1 divided by mod of a into f of b by a. Yes, have you people got this shifting property? These are the general formulas, or you can call it as the shifting property. Yes, that comes in the Dirac delta function. Okay, instead of a, what we have, instead of a, we have a, which is equal to 3 from the question, and instead of b, what we have, the b value, which is equal to 5. So substitute in this solution, that is equal to 1 divided by mod of 3. Instead of a, it is 3, and the function of b by a, what is the function here? That is f of x, which is equal to 2x plus 3, right? Yes. Now the function of b by a, what is b? It is 5, divided by a is 3. So instead of x, I need to substitute as 5 by 3 plus 3. So it is 2 5s are 10, divided by 3 plus 3. Taking the LCM is 3. 10 cross multiply, it is 9. 10 plus 9 is 19 into 19 divided by 3. Okay, so the mod will take the positive value. So 19 divided by 3 into 3 is 9. So the correct answer is 19 by 9. So which is the correct option? Option 2 is the right answer. Yes, let us proceed to the next question. What is the value of closed integral c dz by z, where c is a circular path of radius 2 centered at the origin and the integration is done anti-clockwise direction? They have given the integral, that is dz divided by z. Okay, and they have given the radius of this circular part to be 2. Okay, this problem can be solved using Cauchy's integral formula. Okay, what does the formula says? Means the integral over closed path is equal, that is f of z into dz divided by z minus a, which is equal to 2 pi I into function of a. Okay, yeah, compare with the question here. What is a which is equal to, the value is 0. So if I get a to be 0 means it lies inside, means a radius which is equal to 0, the point lie it's inside only. If the point lie inside means the integral cannot be 0, so integral as some values. So apply in the formula, instead of f of z, what we have here, instead of f of z we have 1 here. So f of z which is equal to 1, what is the value for f of a? F of a will be 1. So after applying the formula, we get it is 2 pi I, instead of f of a, it is 1. So the solution is just 2 pi I. So which is the correct option? Option 4 is the right option. So let us proceed with the next question. A pendulum consists of a ring of mass m and radius r, suspended by a massless rigid rod of length L attached to its rim. When the pendulum oscillates in the plane of the ring, the time period of the oscillation is. So, in this question, we have the formula time period which is equal to 2 pi square root of I divided by mg into d. What is here? D means complete length of the rigid rod as well as the radius of the ring, and I is the moment of inertia, and m is the mass, and g is the acceleration due to gravity. First, I want to find I. I is nothing but moment of inertia at the center of mass plus m into complete length square. So, moment of inertia at the center of mass we have, that is m into r square. So, what is d here? D is nothing but complete length of the rigid rod plus the radius of the circular ring. So d value will be L plus R. So substituting the values, we'll get I which is equal to m r square plus m into, instead of d it is L plus R whole square, or using a plus b whole square formula I can solve this. It is mr square plus m into L square plus m into r square plus 2 times of m into lr, right? Mr square I can write it as 2 times of mr square. M is everywhere common, I can take it outside. It is r square, 2 times of r square plus L square plus 2 times of L into R. This is the value for I we got. So substitute in the above time period equation the time period which is equal to 2 pi square root of m into 2r square plus L square plus 2 times of LR, all divided by, small m and capital M is one and the same, it is the mass of the system. So m into g into d, m get cancels. Instead of d, what I want to write, it is L plus R. So time period t which is equal to 2 pi root of 2r square plus L square plus 2 times of LR divided by, whole divided by g into L plus R. This is the solution. Let us go back to the slide and see which is the correct answer. The correct answer is option C. Option C is the right answer. Yes. Yeah. Let us move to the next question. What does the question says? The Lagrangian of the particle moving in a plane is given in Cartesian coordinates as Lagrangian L, which is equal to x dot y dot minus x square minus y square. In polar coordinates, the expression for the canonical momentum, that is PR, conjugate to the radial coordinate r is. So solving this, I have taken the equation, the Lagrangian, which was given in the question. Yes. So what we have, x in terms of polar coordinates. Yeah, we know that x in terms of polar coordinates which is equal to r cos theta, and y in terms of polar coordinate, which is equal to r sin theta, right? So we got the x value in polar coordinates, which is equal to r cos theta, and y in terms of polar coordinates to be y r sin theta. And here we have one more thing, that is x dot and y dot. So let us differentiate and write. After differentiating and writing, we got x dot value to be r dot cos theta minus r sin theta into theta dot, and the y dot value, which is equal to one time differentiating. So we'll get the value r dot sin theta minus, sorry, it will be plus r cos theta into theta dot. This is the value. So we must know these values for solving the problems easily. Okay, yes, let us substitute these values in the question given here. So what will get l, it is equal to x dot value is r dot cos theta minus r sin theta into theta dot. What is y dot value? Y dot value is r dot sin theta plus r into cos theta theta dot. Yes, minus x square. X square will be r square cos square theta minus y square will be r square sin square theta. After substituting, this is the value. Yes, now I want what they have given. I want the value for P of R, that is a canonical conjugate, right? For finding P of R, the formula is dou L divided by dou R dot. It is a partial differentiation of Lagrangian with respect to R dot. Okay, let us do this. So r dot into r dot, it will be r dot square. After doing partial differentiation, it is 2 times of r dot, and theta remains here constant. We'll get sin theta into cos theta. Next, doing with the next term, r dot into r, differentiation of r dot is 1, r remains same as it is, and cos square theta remains as it is into theta dot. Yes, next, differentiating with the next term, it is minus r sin theta into theta dot, r dot sin theta. So r remains constant here, so it will be minus r sin square theta into theta dot. In the last term, what we have, uh, minus r sin theta into theta dot plus r cos theta into theta dot. We don't have the r that term, so in the next two terms also we don't have the or dot terms. So this is the end of the differentiation. Now solving this equation, so r dot, take it out and rearrange the term, it will be 2 times of sin theta into cos theta, plus here I can take r and theta dot common. So r theta dot I am taking common, it will be cos square theta minus sin square theta, right? So 2 times of sin theta cos theta, how can I write? I can write it as sin 2 theta, right? Plus r into theta dot cos square theta minus sin square theta, I can write it as cos 2 theta. These are the general formulas, and this is the formula for canonical conjugate. Yes, canonical conjugate momentum, I can call it as, okay, PR. Next, this is the end of the session. In the next class, I'll be doing more problems. Thank you for watching.